All right, guys, good afternoon. Sorry, Ms. Dvorak and I are both not here this period. So we're going to give you a quick video lesson, and then we'll follow up with you tomorrow in class more about this stuff. But for today, make sure you guys have your notes open. So this is lesson 5, and following along, and then you're going to try the exit slip. And then, like I said, we'll do more of this stuff tomorrow just to follow up with you, make sure you got it, but you need to follow along today, okay? So again, open up lesson 5, and then if the sub wants to pause me for a second and hand out any paper copies, let's do that right now. Okay, so we've been talking about functions, so we're gonna graph them today. So before we jump into like how to do all these transformations and stuff, we're gonna just talk about the graphs, okay? So there's 2 main functions that we're going to talk about. So the first one is the square root of x. Okay, we've actually graphed this before. We did this first semester. But if you want to graph something, you can always make a table. Okay, so I'm going to graph the square root of x. So if I pick some numbers, like if I just pick 0, that means I'm plugging in 0. Okay, so I'm going to do the square root of 0. That's 0. So that's a point, 0, 0. Okay, if I just go down the line, I pick 1. That means I'm going to do the square root of 1. Well, the square root of 1 is 1. Okay, so that's another point, 1, 1. Now, if I just pick 2, that means the square root of 2, but there is no number. When you multiply it by itself, you get 2. That's a nice number. It's like 1.4 something. So I'm not going to pick that. If you think about the next nice, perfect square, that's 4, because the square root of 4 is 2. Okay? As you go on, they don't fit on the graph anymore. Like you could do 9 because the square root of 9 is 3. It's a little off the graph. So these 3 points are fine. Now, if you think about negative numbers, you can't do the square root of negative 1 because that's like I, right? You can't see imaginary things. So these are your points. Okay, so that is the square root function. Graph those 3 points because you're going to need them later. Okay. As far as domain and range, remember domain is your x's. So the first x value of this graph is 0, and then it goes to the right forever. Remember numbers, you use brackets. Range is your y's, so that's down to up. So the first y value is 0, and then this goes up forever. Okay, so that's just a little bit of review. So that's the square root function. Okay, the one that we have not talked about yet is the cubed root. So this means what number times itself 3 times gives you whatever number you picked. Okay, so if I pick the same numbers, like if I pick 0, that means the cubed root of 0. Well, the cubed root now means what number times itself 3 times gives you that number you picked. So 0 times 0 times 0 is 0. Okay, so that's a point, 0, 0. I could pick 1. Okay, the cubed root of 1, well, 1 times 1 times 1 gives you 1. So 1, 1 is another point. Okay, if you kind of see the pattern that we're picking, the next one would be doing 2 times 2 times 2. So 2 times 2 times 2 is actually 8. Okay, so that's the next nice cube root. The cubed root of 8 is 2. Okay, so if you just graph this part, that looks very similar to the other graph, but this one you're allowed to do some other things. I can actually do negative numbers, because if I do the cubed root of negative 1, I can do negative 1 times negative 1 times negative 1. It's 2 negatives, make a positive, times another negative is a negative. Okay, so negative 1 is a point. So if you just think about what the cubed root of negative 8 would be, that would be negative 2, right? It's the same as the positives, but negative. Okay, so negative 8 and negative 2 goes right here, connect them. So this graph kind of looks like a flat S shape. Okay, domain and range for this one are nice because they're actually the same thing. It goes left and right forever, and it goes up and down forever. Okay, so when you graph these, you're not going to have to make a table every time. Okay, you just have to lock in, like remember what these pictures look like. If you remember those points, you'll be good. Okay, so those are called the parent functions. They're the most basic functions. Okay, so we have talked about this next part before too, so here's just a reminder. When you are transforming a graph, okay, there's different things that can happen. So here's the square root, the cube root. Notice the letters are all the same. For the a value, oops, that's a highlighter. If a is negative, okay, if there's a negative sign out front, that means your graph is flipping over the x-axis. We've talked about that before. Okay, if there's a negative in front, you flip your graph. Okay, if there's something inside the square root or the cube root, h is inside. That number, you move your graph either left or right, but you do the opposite of what it says. So if it said like x minus 2, you'd go right 2. Okay, and then the k is whatever is outside the root. That you either, oops, that's outside. You either go up or down, and you just do what it says. Okay, so just take a second right now, make sure you have those 3 things written down, and then we're going to do a couple examples. Okay, if the sub needs to pause me for a second, you can do that. But I'm going to graph one. Okay, so I'm going to go to number 1. So I want to graph this function. So the first thing that you have to do is figure out what's the parent function. The parent function is what type of root it is. There's no 3 right here, so this is just the square root. Okay, so what I want you to do is go back up to the square root graph and plot those exact same 3 points. So 0, 0, 1, 1, and 4, 2. 0, 0, 1, 1, and 4, 2. Okay, this was the parent graph. It's the same exact thing as we plotted above. Okay, now what we're going to do is move it or transform it based on the numbers that you see. Okay, so I see a +2 on the inside. So inside means left or right, but do the opposite. So this means left 2. And then that -3 is on the outside. Outside means up or down. You just do what it says. So this means down 3. Okay, so we're going to go left 2, down 3. So you're going to take all 3 of those points and go left 2, down 3. Left 2, down 3. Left 2, down 3. Okay, and then you have your new picture, and this is your final graph. Okay, your domain and range are always based on the final, because that's the problem you're graphing. Okay, so the domain is your x's. This is kind of just review stuff. So the first x value that you hit is right here at -2, and then it goes to the right. The first y value that you hit is right here at -3, and it goes up. Okay, so it should look like you took that original graph and shifted it left 2, down 3. Okay, so that's it for that one. Okay, I'm going to skip 2. I don't want this video to be terribly long, so I'm going to go down to number 5. Okay, so first thing you want to do is just figure out what graph is this. Okay, as soon as I see this little 3 here, that means it's the cube root function. Okay, so I'm going to go way back up to the top. Here was the cube root function. I'm going to plot these 5 points. Okay, so 0, 0, 1, 1, 8, 2, and then the negatives. Okay, so take a moment, plot those same 5 points as we did from up above, and graph that. That's your parent function. Okay, again, if the sub needs to pause me for a second, just get everybody to graph those 5 points. Oops, sorry, I went to number 3. This is number 5. My bad. Same function. If you need to fix that, take a second. Okay, so now we need to say how this is moving. All right, so this has a negative sign in front. So if you flip way back up to that box we filled out, the negative in front means there's a flip over the x-axis. So we can just say flip, but then there's also this +5 on the outside. Okay, anything outside means up or down, so this means up 5. Okay, so we're gonna do those 2 things to this graph. So the flipping is what I want to talk about. You always flip over the x-axis. So here's the x-axis. We're treating it like a mirror. Okay, so if I'm flipping my point 0, 0, that's already on the line, so that's not going to change any. That's going to stay right there. Okay, this point 1, 1, if I flip it over my line, it's going to go right here. The one all the way to the right, if I flip that over my line, that's 2 above, I'm going to flip it 2 below. Okay, this one is 1 below, I'm going to flip it to 1 above, and then same thing here. So treat that line like a mirror, and then connect these. And then you don't really need those other lines I drew, but that's fine. And then this is your final answer. Okay? So the domain and range again is nice because it goes left and right forever, and it goes up and down forever. Okay? So that's how you flip a graph. I just wanted to make sure I showed you one of those. Okay? So on your exit slip today, you're going to have to make 2 of those graphs just like we just did. So make sure you figure out what's the parent function, graph it. So just copy the points from up here, and then how's it moving. Okay? Your other questions are just quick, like what's happening to this graph, you drag and drop, that kind of thing. Okay? So from now until when the bell rings, you should be working on the lesson 5 exit slip. Okay, we're not going to start this over tomorrow. So tomorrow in class, Ms. Dvorak and I will do a couple extra practice examples, see what you had questions on, and then we're going to move on. Okay? Email us if you need anything. We're both just in meetings, but we will see you guys tomorrow. Okay? Have a great day.